Greetings, mathematicians. In this video, we are going to do some combination type problems where we're putting lots of different exponent rules together in the same problem. Now, what's a little bit challenging about these is that although you should end up with the same answer as someone else, your work might look very different. So keep that in mind as you go. So for our first problem here, we've got this problem, and we're going to give this a try. So first up, remember from elementary school that when you multiply fractions, you multiply straight across the top and straight across the bottom to get your new numerator and denominator. So for our new numerator, we're going to do, we're going to look at this as kind of like mini problems. We'll look at just the numerical part and then the different variables. So 3 times 12, that's 36. X cubed times x squared, that is x to the 5th. Y times y squared, remember if there's no exponent it's like a 1, so that would be y cubed. And then do the same thing in the denominator. Remember if there's no coefficient that's like a 1, so that's like a 4 times 1 to give you a 4. And then we've got an x times y cubed. Next up, start to look for things that we can simplify and reduce. Again, kind of think of this as a separate group of mini problems. So just look at the constants and then the x's and then the y's. So for the constants, we've got 36 over 4. That's just 9. For the x's, we've got x to the 5th over x. Remember, if there's no exponent, it's kind of like a 1. So that would be 5 minus 1, which is 4, so x to the 4th. And now we've got y cubed over y cubed. So 3 minus 3 is 0. And anything to the 0 power is 1. And 1 times anything is itself. So final answer is 9x to the 4th. Again, you may have chosen to apply the exponent rules in a different order or different exponent rules altogether, depending on how you approach the problem, but you should end up with that same solution. All right, here's our next one. Usually for order of operations, we like to start with those parentheses, so we're going to go ahead and focus on this part of the problem that has parentheses first. So we're going to kind of leave the part without parentheses alone for a while. And we're going to use this power of a quotient rule first, where we apply the exponent to each part first. So when we take the x squared and we raise it to the negative 3rd power, that's our power to a power rule where we keep the same base and we multiply the exponents. Same thing in the denominator. Remember, there's no exponent on the y there, so that's like a y to the 1st. So 1 times negative 3 is negative 3. And then as we multiply fractions, remember we multiply straight across the top and straight across the bottom. And this is our rule where we keep the same base and we add the exponents. So we keep the x's, and we, using the product rule, we do 1 plus negative 6 and we get negative 5. And then we do negative 1 plus negative 3 and we get negative 4. And then our last exponent rule here is where we don't like to have negative exponents, so we're going to change their location in the fraction. So a negative exponent in the denominator moves to the numerator and becomes positive. A negative exponent in the numerator moves to the denominator and becomes positive. So that's our final answer here. Y to the 4th over x to the 5th. Again, you might have had a different order of steps and applied different exponent rules, but you should end up with the same solution. All right, and we've got one more problem similar to the last two. Again, we're going to multiply straight across the top, straight across the bottom when we multiply fractions. And again, split these up into constants and then the different types of variables. So constants first, we've got the 2 times the 9. Then we've got x's. We've got x squared times x using our product rule. 2 plus 1 is 3. Then we've got y's next. 1 plus 2 is 3. Then we've got our denominators. And since we don't have any factors that are the same, we've kind of just got each of these things times 1 essentially, and they basically stay the same. Then we're looking for things that we can simplify. So we've got 18 divided by 3. We've got x squared, or x cubed divided by x is x squared. And y cubed divided by y to the 4th. Remember, that is where you would subtract the exponents. So 3 minus 4 is negative 1. And then when you have a negative exponent, it goes to the opposite place in the fraction. So it was in the numerator, it now goes to the denominator and becomes positive. All right, so this is our last problem of the day, and it looks a little different than the previous ones. What we want to do here is we're trying to figure out what values we should put in for the a and the b over here on the left-hand side of the equal sign so that the two expressions would be equal to each other. So the best way to attack this is going to be to simplify the left-hand side as much as we can so that it ends up looking like the right-hand side. And then we want to try to make things look the same. So what we can see is already the same. For example, we see that we already have the 4w squared that looks exactly the same on both sides. So that's a good start. Other than that, we see a lot of things that look different. So what I would be tempted to do next, on the left-hand side, I see that I have parentheses, but I don't have any on the right-hand side. So I'm going to want to try to do something to get rid of those parentheses. So what I'm going to do is try to use my power of a product rule to apply that negative 4 exponent to each of those factors and try to simplify that. So I'm just working on the left-hand side for now. And what I see next is these two factors can be simplified a little bit more because those are power to a power where you keep the same base and you multiply the exponents. So, for example, b times negative 4 is negative 4b, and a times negative 4 is negative 4a. Now, things are starting to look a little bit better. This is starting to look a little bit more like this. I've gotten rid of the parentheses at least. I still have the 4w squared in the denominator, but I need some other things in the denominator. I need to get this part with the base of 5 in the denominator. And if I look over on the left-hand side, I can see that's actually going to happen pretty easily because my factor that has a 5 in it has a negative exponent, and we know that things with negative exponents like to move and become positive exponents. So this is actually just going to move down to the denominator and become a positive exponent. The other thing I see here is this h factor. That's also in the denominator. So I'm going to take this, and again, luckily it has a negative exponent. That's going to move to the denominator and become a positive exponent. Now the last thing is that this w here has a negative exponent, and I should be tempted to move it to the bottom, but if I move it to the denominator, this is no longer going to match the 4w squared over here. So I'm actually going to leave it where it is. And it actually matches up a little bit better on the other side, because on the right hand side of the equation I've got this w to the 16, and it kind of matches up with this being w to something. So let's see what I've got now. I have the 5 to the 4th that matches, the 4w squared that matches. I've got h to some power that matches h to the 20th. I've got w to some power that matches w to the 16th. So I think I'm in a pretty good place where I can start to figure out what the a and the b are. So for the w to the negative 4b, that's matching up with my w to the 16th. And that's going to allow me to figure out what b is. In order for these terms, or these factors to be equal to each other, the negative 4b exponent has to be equal to the 16 exponent. If I divide both sides by negative 4, that tells me that my b has to be the negative 4. And then similarly, if these h terms, these h factors, if they're going to be the same, then this 4a has to be the same as this 20. And divide both sides by 4. So then a has to be 5. So to answer my question, the values for a and b, a has to be 5 and b has to be negative 4 for these two expressions to be equal to each other. All right, and we're going to stop there for now and let you move on to your practice problems next. So thanks for joining us today. Bye for now.